Hello, my name is Mr. Asprey. This is EDEXCEL June 2018. It's the first ever A-level paper from the new spec, and I'm going to go through it in its entirety right now. So hope you enjoy it. If you do, like and subscribe, all that jazz. Let's get going. We need to know our small angle approximations. Cos theta is 1 minus theta squared over 2. Sine theta is theta. So when theta is measured in radians and is small, then we can use these as an approximation. So, given that we have 1 minus cos 4 theta over 2 theta sine 3 theta, we can replace these out. And in doing so, we'll get 1 minus 4 theta all squared over 2. So I've replaced the theta with a 4 theta. So it's no longer just theta there, it's 4 theta because this is cos 4 theta. Making sure you put it in brackets so that you don't forget to square the 4 as well. Over 2 theta, and then sine 3 theta will be just 3 theta. Okay, great. Now we need to simplify this. So we're going to get 1 minus 1, which cancels. We're going to get minus 4 theta squared, which is going to give me 16 theta squared, and that's over 2. And on the bottom, we've got 2 theta times 3 theta, which is 6 theta squared. Okay, so the top is 8 theta squared. And simplifying this, the theta squared is going to cancel, and 8 over 6 is 4 over 3. Bosh. Question number 2, and we are going to be differentiating. So first off, I need to write it in the form where I can differentiate it. So the problem piece here is this root x. We can write that as x to the power of a half. Okay, next I'm going to find dy by dx. So we bring the power down and then drop the power down by 1 to make 1. Minus 2x differentiates to just minus 2. Again, bring the power down, so times 24 by a half gives me 12, and then drop the power down by 1. Okay, and then we've got to go again. We're going to differentiate again. So 2x differentiates to 2. Minus 2 is a constant, so that differentiates to 0. Minus a half times by minus 12 is plus 6, and drop the power down by 1. Again, it gives you minus 3 over 2. Verify C has a stationary point at x equals 4. Okay, so terminology here. The word verify means we don't need to find or show, we just need to check that it works. So I can literally just substitute in and see if that works. So I'm going to sub in x equals 4 into dy by dx. So I get dy by dx equals 2 lots of 4 minus 2 minus 12 lots of 4 to the minus a half. That gives me 8 minus 2, and 4 to the half is 2, to the negative power is 1 over 2, times by minus 12 is minus 6. Perfect, this gives me 0, therefore stationary. Okay, great. Next part, determine the nature of this stationary point. Well, we need to substitute into the second derivative in order to tell us what the stationary point is. So second derivative at x equals 4. What does this give us? Well, we've got 2 plus 6 lots of 4 to the negative 3 over 2. Which is 2 plus square root the 4 gives you 2. Cube it gives you 8. Negative power 1 over 8. So 6 times 1 over 8 is 6 over 8. Okay, so this is 2 3/4, so 2.75, and that is greater than 0. That's positive. And when the second derivative is positive, that means it is a minimum. Bosh. Question number 3, and we have a sector of a circle. The angle's in radians, and the area of the circle is 11. Given that the perimeter of the circle, the sector, sorry, is 4 times the length of the arc AB, find the exact value of R. Okay, so first off, the first bit of information we've got is that the area is 11. And we know the area, which is 11, is equal to a half R squared theta. So 22 is equal to R squared theta. We can't do much more with that because they've got 2 unknowns. Now we know that the perimeter of the sector, so the perimeter of the sector, first of all, let's find what the arc length is. Well, arc length is equal to R theta, using our formulas for the arc length. And we know that the perimeter is 4 times bigger than that. So the perimeter is R plus AB. And that is 4 times bigger than that. So what we can say is R plus AB is 4 times by AB. So this gives us 2R plus R theta is equal to 4R theta. Minusing R theta from both sides gives me 3R theta on that side. And then dividing through by R gives me 2 is equal to 3 theta, which means that theta is equal to 2 over 3. Okay, great. So now we can use our first formula that we created, and we can say that 22 is equal to R squared theta. So 22 is equal to R squared times 2 over 3. Divide both sides by 2. Times both sides by 3. And then square root. It says the exact length, so it's the square root of 33. Obviously it has to be positive because it's a distance. Bosh. Question number 4. We have y equals 2 ln 8 minus x, and that meets the line y equals x at a single point x equals alpha. Okay, so that alpha is between 3 and 4. Well, if the 2 lines meet, then we set them equal to each other. And then I'm going to move the x to the other side to make it equal to 0. Okay, now if alpha solves this equation and is between 3 and 4, then it means that if I sub in x equals 3 and x equals 4, I should get a change of sign, which shows that the root is in between those 2 points. Okay, so I'm going to do 2 ln 8 minus 3 minus 3 and see what that gets, and I'll do 2 ln 8 minus 4 and see what that gets. I'm going to do that on my calculator now. Okay, substituting those in, I got a positive 1 for the value of x equals 3 and a negative 1 for x equals 4. We can say therefore, as a change of sign, alpha is in between 3 and 4. That should do the job. Okay, next. Right, part B. I'm recording this post completing the paper, and I wanted to re-record this particular part because I didn't feel like I explained it very well, and I want to do a better job of it right now. So this question is basically asking you to start at x equals 4 and show on the graph how it will converge upon alpha, or whether it will do. Well, I know it does. This is the iterative formula that we're going to use. So if you need to do this just using your calculator, what you would do is you would type in 4 equals, and that tells you that the first answer is 4. And then we're going to use the formula, which is 2 ln 8 minus the previous answer, which we can use the answer button for, and we can press equals. So that tells me that x2 is 2.77. Okay, now how does this work on the graph? Well, you start with x equals 4 and you sub it in to the formula. And the formula is the same as this curve, so we're going to get an answer come out in terms of y, and that's going to be 2.77. So that value there is 2.77. Now what I need to do is I need to sub in my next x value, which is going to be 2.77. Now where is 2.77? Well, it's actually right here. And I know it's right there because this is the line y equals x, where the y values, the y values and the x values are the same. So my y value that I got from substituting in x as 4 is going to be used as my next x value. So what that means is I can just do this by hand. I don't need to actually work out what the x values are. I need to just go up to the curve, like I've done here, and then just go across to the line y equals x. And that will convert my y value that I get for subbing in into the same x value. So in practice, it looks like this. We go up to the curve, which gets a value of 2.77. We go across, and that tells me exactly where x is 2.77. And then I can go up to the curve again, and this is where I get my x free value, which I could use my calculator to do, 3.30. So therefore we know that the next x value needs to be 3.30. So what I could do is I could just go over along this line to y equals x, and that will give me the perfect position for 3.30. And then what I do, I can repeat. I go from that point down, in this case, to the curve, and then I would go, well, we can't do it anymore because it's just got too precise, but that is the pattern that we do. So we go to the curve, to the line y equals x. We go to the curve, to the line y equals x, and then we go back to the curve, and then across to y equals x, and then back to the curve, and so on and so forth. And we get this cobweb pattern, and that shows that it will converge on the root. Bosh! Let's go. Question 5, and we have some trig, and we are differentiating. And this looks like the quotient rule because we've got a fraction. Okay, so dy by d theta. Well, first off, what we need to do is we need to define that u is the top of the fraction, which is equal to 3 sine theta, and v, which is the bottom of the fraction, is equal to 2 sine theta plus 2 cos theta. Okay, so we can differentiate both of these. When I differentiate 3 sine theta, I get 3 cos theta. When I differentiate 2 sine theta, I get 2 cos theta. And when I differentiate 2 cos theta, I get minus 2 sine theta. Okay, so now we can use the quotient rule, which is v multiplied by du by dx minus u multiplied by dv by dx all over v squared. So this is going to be 2 sine theta plus 2 cos theta multiplied by du by dx, which is 3 cos theta, minus u which is 3 sine theta, times by dv, which is 2 cos theta minus 2 sine theta. And all of that is divided by 2 sine theta plus 2 cos theta all squared. Okay, right. I guess I didn't expect it to be super easy, but it looks like we're going to have to do some expanding here. So I'm going to give myself some space. So when I expand out the top, I get 6 sine theta cos theta plus 6 cos squared theta minus 6 sine theta cos theta and plus 6 sine squared theta. Okay, and when I do that double bracket there, I'm going to get 4 sine squared theta. I'm going to get plus 4 sine theta cos theta plus another 4 sine theta cos theta plus 4 cos squared theta. Okay, right, I've spotted that this plus this, that's a lovely identity. That's going to give me 6, because of course cos squared plus sine squared is 1, so times that by 6, I'm going to get 6. And oh, beautiful, look at that, this is going to cancel. Excellent. So the top line is just 6. Okay, on the bottom, we've got that again. We've got this lovely identity here. You add those two together, you're going to get 4. And here we've got 8 lots of sine theta cos theta. And we're going to use another lovely identity, which is that sine 2 theta is equal to 2 cos theta sine theta. So timesing both sides by 4 will give us what we have over here. Okay, so therefore this becomes 6, 4 plus 4 sine 2 theta. And we can do a little bit of factorising here. Take out 4, which gives me this. And then I can, I guess, kind of move the 4 up, and it becomes a divide by 4 on top. So 6 over 4, like that. And that gives it in the form that they have asked for. So simplifying that is 3 over 2. So A is equal to 3 over 2. Beautiful. Question 6, and this looks lovely. Centre with, circle with centre 5, 7, 5. We've got a line with that equation, and it's tangent to the circle at the point P. As shown in the diagram, show that an equation of the line PA is given as 2 y plus x equals 17. Okay, so we know already a point on that line because we know A, and we also know that because the radius PA is the radius of the circle and it hits the tangent there, it will hit it at 90 degrees, so that is a 90-degree angle there. So therefore we know the gradient of PA. So the gradient of PA is the negative reciprocal of the gradient of the tangent. So it's -1/2. And we also know a point on PA is 7, 5. So we can do y minus y1 is equal to m x minus x1, the equation of a straight line. Timesing by 2 gives me 2y minus 10, and then multiplying out that bracket by minus 1 gives me minus x plus 7, and then bringing the x to the other side turns it positive, and bringing the 10 to the other side turns that positive to make 17. Lovely. That's part A done. Part B says find an equation for C. Okay, so what we need is the radius, which is the distance of AP. So if we knew what P was, then we would be able to find the radius. Okay, so how are we going to find P? Well, P is where the line L and the line we've just created intersect. So what we need to solve is 2y plus x equals 17 needs to be solved with y equals 2x plus 1. So we can solve these two simultaneously. That gives us the point P. And I will do that, I guess, by I'll do substitution. So equation 1 and equation 2, let's sub 2 into 1. So I write 2, and instead of y, I'm going to write 2x plus 1 plus x equals 17. So I've just rewritten equation 1, but I've replaced the y with the y is equal to 2x plus 1 from equation 2. So that gives me 4x plus 2 plus x equals 17, which gives me 5x must equal 15, which gives me x equals 3. So going back and solving, subbing into equation 2, gives me y is equal to 2 lots of x plus 1, which is equal to 7. Okay, so that tells me that P is at the point 3, 7. So now what I need to do is find the distance. The radius is equal to the distance of P to A. So we do that by doing the square root of, whoops, didn't mean to do that. The square root of the difference in the x coordinates, because what we're doing is we're just creating a tiny right angle triangle, and the difference in the x coordinates is the base of the triangle. So the difference in the x coordinates are, well, we've got 7 over here and we've got 3 here, so it has a difference of 4. And then we need to add on the difference in the y coordinates, so we have 5 here and we've got 7 here, so that's a difference of 2. Okay, so the radius is the square root of 20. Okay, and then the equation of the circle is x minus the centre x coordinate, which is 7, plus y minus the centre y coordinate, which is 5, all squared, as I've written down, is equal to r squared, which is 20. Okay, great. Okay, part C, I'll do this over here, I think I've got space. It says the line with this equation is also tangent to C. And, okay, so that equation must be the line, which I'm about to draw on now. It must look something like this. And it must be parallel to the line L, so it must have the same gradient of the line L, obviously it does, yeah. But it's got a different y-intercept. What we could do is we can use like a stepping stone method in order to get this point here, which we need. Let's call this point Q. So if I draw this diameter across like that, and I'm going to zoom in actually just so it's really clear to see what we're doing. Okay, we said that the change in the x coordinates were 4. And we said the change in the y coordinates were 2. Because P was the point 3, 7, and then A, the centre, was the point 7, 5. So to get from P to A, you've got to shift along 4 in the x coordinate. So to get to Q, because of symmetry, I need to shift on another 4 on the x coordinate. So I'll get to 11. And the y goes down by 2. So to get to Q, the y needs to go down by 2 again. So we're creating this sort of like a staircase almost to get to Q, using the symmetry of the circle. Okay, so now I have Q, and I know the gradient of the orange line. Oh, actually, sorry, the green line. I'll just finish it off here. So we know that y is equal to 2x plus k. We know that it goes through Q, so the y coordinate is 3. The x coordinate is 11 plus k. So we get 3 is equal to 22 plus k. So k is equal to minus 19. Job done. Bosh. Okay, let's go. Integration, and it says show that this integral is independent of k. Okay. Well, let's integrate it then. So we are integrating between 3k and k 2 over 3x minus k with respect to x. Now what I can do is I can take out a factor, because what we want is we want the denominator's derivative to be the numerator, and that way we can use the Lund rule. So the denominator's derivative is 3, so I want the top to be 3, so I could times the top by 3 over 2. And if I've times this by 3 over 2, means I need to take out a 2 over 3 outside to cancel that out. Okay, perfect. So now this is the same as 2 over 3, the integral between 3k, k, and 3 over 3k minus 3x minus k. And when I integrate that, because the denominator's derivative is the numerator, I can write that as ln of the denominator. And there's a 2/3 outside, and I'm going between 3k and k. Okay, great. Now I just need to sub in. So when I sub in, when I sub in 3k, I get ln of 9k minus k is 8k. And then when I sub in 1k, I will get ln of 3k minus k, which is 2k. Okay, great. So we've done the upper bound subbed in, subtract the lower bound subbed in. Okay. So when we subtract lns, we can convert it into a single ln, but we need to divide the two inputs. So this becomes 2/3 ln of 8k over 2k, which is equal to 2/3 of ln of 8 over 2, which is 4. And this is independent of k. There is no k in that solution. So that is good. Okay, great. Part B. I'll start that here. Now we're integrating between 2k and k, and this we can write as 2x minus k to the power of minus 2. Okay, so we can just integrate this normally as it's just a bracket. So what we do is we up the power of the bracket, and that will give us minus 1. We divide by the new power, and we divide by the derivative of inside the bracket. So that means I need to divide by 2 as well. So there's a 2 on the bottom, and there's also a 2 here from the start. Okay. So this gives us, well, the 2's will cancel here and here. There's a negative there, so it's negative 2x minus k to the minus 1. And that is between 2k and k. Okay, let me just create some more space. Okay, so I've got to substitute my values in now. So subbing in, I might rewrite this actually as 1 over, or negative 1 over 2x minus k. And I've got 2k and k. Okay, so subbing in, I will get minus 1 over, so 2k times 2 is 4k minus k is 3k. And then we're taking away the lower bound, which will be 2k minus 1k, which is just k. Okay, let's make the numerators, sorry, the denominators the same by timesing through by 3 top and bottom with that one. Okay, so what is this? This is minus 1 over 3k minus 3 over 3k. So that's minus 1 minus 3 is plus 2. So therefore this must be 2 over 3k. Okay, great. And this is inversely proportional to k because it's over k. So we can just write here inversely proportional. Sounds good. Question 8, and we have a harbour, and there's a depth of water given by that formula. The boat enters the harbour at 6:30 AM and it takes 2 hours to load its cargo. The boat requires the depth of the water to be at least 3.8 meters before it can leave the harbour. Find the depth of the water in the harbour when the boat enters the harbour. Okay, so that's at well, 6:30 AM. And seeing as that t is the number of hours after midnight, then that gives us a t value of 6.5. So the depth is equal to 5 plus 2 sine 30 times 6.5, which we could do on our calculator. So 5 plus 2 sine 30 times 6.5, so 4.48. And we need to use the correct units there, meters. Okay, great. It says find the nearest minute the earliest time the boat can leave the harbour. Okay, so what we need to do is we need to set the depth equal to 3.8 in order to solve this, to find the correct time. 30t. Okay, so solving this equation, it gives me minus 1.2 equals 2 sine 30t. Divide through by 2 gives me this, and then we need to do sine to the minus 1 in order to find that value for t. So sine to the minus 1 of minus 0.6. Okay, okay, that's 30t, isn't it? Yes. Okay, that's so 30t equals minus 36.86 or 87. Okay, so as soon as you press sine to the minus 1 on your calculator to find a trig solution, then you need to find the second solution straight away. So you do that by doing 180 minus for sine. For cos it's 360 minus, for tan it's 180 plus. Excuse me, and that gives me 216.87. Okay, and I might just find a third solution as well, just because I reckon I might need it. It's just easier to do it now. So 36.87, sorry, we add on 360. So you can always just add on 360s to find the next solution. So you find your first two. Yeah, so you find your first two. This is number 1, that's number 2. And then you can just add on 360 to both of these to find the next solutions. Okay, so now what I can do is I can divide that by 30. I can divide all of them by 30. And look, there's not much point in me doing the first one, is there? It's negative. I'm not going to get a good time out of that one. That's no good. Divide this one by 30. That could work. I mean, while I'm here, I'm just going to divide that one by 30. That gives me 10.77. But let's go with this one, 216.87. Divide that by 30. And we get 7.22. Okay, now this question is tricky because you need to actually read the question really carefully. They need to unload their cargo for 2 hours. So the earliest it can leave is 8:30 AM. Because they need to get rid of all the cargo. They're not just going to leave straight away. Which rules out this one. This one's ruled out. It's too early. So this one is the good one. And it says the nearest minute as well. So I need to find out what 0.77 is of an hour. Okay, so it's 46. So the time we're looking for is 10:46. Perfect. Implicit differentiation. Question 9. It says there's the curve, and it says find dy by dx. Okay, so I've got to differentiate this implicitly, and this is going to give me 2x, and this is a product, so I will differentiate the 2x part first to get 2, and I'll leave the y alone, and then I will leave the minus 2x alone, and I'll differentiate the y to get dy by dx. And when I differentiate this function with respect to y, I get 6y, but because I'm differentiating with respect to x, I need to multiply it by dy by dx. And that equals 0. Okay, I will pick up all of the non-dy by dx terms, move them to the other side, and I'll also factorise out a dy by dx of what's left. So dy by dx, we have a 6y and a minus 2x, And then these are going to go to the other side to get 2y positive and 2x negative. We're then going to divide through by that factor to get 2y minus x over 6y minus 2x. Oops, sorry, 2x. Top and bottom divide through by 2, and Bob's your uncle, there it is. Okay, now it says that the curve is modelled by the shape of the cycle track, yeah, blah blah blah. P and Q are the furthest west and east. It says using part A, find the exact coordinates of point P. Now point P has a vertical tangent, which means the gradient there is infinite. And the way we find that is by taking the derivative's denominator and setting it equal to 0. So at that particular point, the gradient's denominator is equal to 0. So 3y minus x is equal to 0. So 3y is equal to x. And also at that particular point, it's on the curve, which means it satisfies this equation. So let's sub in what we've just learnt into that equation. So I'm going to replace the x's with 3y's. So it starts off x squared, so that's going to become 3y all squared. We then have minus 2x times y, so minus 2 times 3x times y. And we've got plus 3y squared is equal to 50. Okay, this gives me 9y squared. This gives me minus 6y squared plus 3y squared is equal to 50. So this gives me 12, that gives me 6y squared is equal to 50. And that means that y squared is equal to 50 over 6. So to the calculator, we got the square root of 50 over 6, which is 5 root 3 over 3. Plus or minus, should I say. Okay, quick inspection. I can see that the point I'm looking at, the y value is negative because it's below the x-axis. So the y value I'm looking for is minus 5 root 3 over 3. And what did we say the x value was equal to? X is equal to 3 times y. So times that by 3, I get minus 5 root 3. Okay, there we go. Perfect. Okay, part C is to explain briefly how to find the coordinates of the point that is furthest north of the origin. You do not need to do this calculation. So the point furthest north is where we have a gradient of 0. So that means that the numerator this time will equal 0. So we will say that y is equal to x, solve with the equation, like that. And a bit like last time, we worked out, we used the negative one. When we do this, we will need to choose the positive solutions, because obviously this point up here is in the positive quadrant. We don't want to accidentally find this one down here in the negative quadrant. Okay, question 10. The height of the above the ground of a passenger on a roller coaster can be modelled by a differential equation. Okay, so given that the passenger is 5 meters above the ground at the start of the ride, show that h is equal to that. Oof. Okay. We just basically got to solve this differential equation. So I need to split up the variables. So I'm going to multiply both sides by dt. And that way the right hand side will become the dt side, where I want to keep all my t variables. and the left hand side will be the dh side where I want to keep all my h variables. So let's divide by h, and that gives me 1 over h dh here, and over here I have cos 0.25 t dt all over 40. Yeah, I think we'll leave it like that, and then what we'll do is we'll integrate both sides. Okay, so integrating the left hand side becomes ln h, and integrating this side, well, cos integrates to sine. We can take the 140 out, we don't need to integrate that, so the 1 over 40, we don't need to integrate that. That's a constant. Like I said, cos integrates to sine, but when you integrate, you need to look at the input, which is 0.25t, and we need to divide by the derivative of that, which is 0.25. So we're dividing by 0.25, which is the same as timesing by 4. And then we write plus c on one side of our equation. We need to do it on one side. Okay, so overall we have ln h is equal to, this becomes 1/10 sine 0.25t plus c. Now we need to use the fact that it starts at 5 meters off the floor when t is 0. So when t is 0, h is 5. So this gives me sine of 0.25 times 0, which is sine of 0, which is 0. So therefore c is equal to ln 5. Okay, so that tells me then that my equation is ln h is equal to 1/10 sine of 0.25t plus ln of 5. Okay, now what are we going to do? Right, yeah, I'm going to minus the ln 5 to the other side, which gives me a ln of h minus ln of 5 is equal to, a tenth is the same as 0.1. I'm just going to write it like that because I've just spotted that that's how they have it in their solution. So we get this, and again, if you've got ln h minus ln 5, that's the same as ln of h over 5. And now we can take, we can raise to the power, e to the power of both sides, which cancels out the ln and leaves me with h over 5. And I get e 0.1 sine of 0.25t. And then all that's left to do is for me to multiply through by 5. And I think that is exactly what they have asked for. Yes, it is. Perfect. Okay. Let's go. Part B. State the maximum height of the passenger above the ground. Okay. So how are we going to find the maximum there? Well, H max is going to occur when the well, this is a sine function here, and the sine function maximum value it can take is 1. So the maximum this could possibly be is 1. So let's set it equal to 1. Because again, like I said, the maximum that value the sine function could take is 1. So it'll be 5 5e to the 0.1 times by 1. So it's just 5e to the 0.1, which we could do on our calculator. So 5e to the power of 0.1, we get 5.5, so 5.5, let's go 5.53. Okay, carrying on, it says the passenger reaches the maximum height for the second time t seconds after the start of the ride. Find the value of t. Okay. Right, so like I said before, its maximum is when the sine function is equal to 1. So that's all I need to solve to find the maximum, just when that sine function equals 1. So sine to the minus 1 of both sides, and that will give me sine to the minus 1 of 1 is, are we in radians here? Yeah, I suspect so. So does it actually say? It doesn't say, so if in doubt use radians. So pi over 2 is the first time the sine function equals 1, and then after that it will reach 1 at 5 pi over 2. Timesing both sides by 4 is going to give me 2 pi and 10 pi. I want the second time, so I want 10 pi, which we know is 31.4. So yeah, happy with that. Some beastly binomial. Use binomial expansions to show that this horrible thing is equivalent to this nice expansion. Okay, well, this is the same as 1 plus 4x over, to the power of a half over 1 minus x to the power of a half, which is equal to 1 plus 4x to the power of a half times 1 minus x to the power of minus a half. Okay, let's do that then. Let's do each one separately and then multiply them together. So luckily we don't have to take out any factors here, because these are both 1. Yeah, the constant term is both 1. So just using the formula, for the first one we get 1 plus nx, so the power times by the x, so that's a half times 4x, that's 2x. And then we have 1 half, drop the power down by 1, so minus a half, all divided by 2 factorial, which is 2, multiplied by 4 to the power 2. Okay, so this is equal to 1 plus 2x. This is going to give me a negative. We're going to have an 8 on the bottom, but we're going to have 16 come out of here, so that's just 2, and that's x squared. Okay, let's do it for this one here now. We're going to get 1 again. The first term is going to be the power multiplied by the x, so 2 minuses will cancel out, we'll get a half x. And then the next term will be the power, drop it down by 1, all over 2 factorial, which is 2, and then minus x to the power 2. Okay, so what will this give us? We'll get an 8 from the bottom again. We'll get two negatives make a positive and a 3 on top. And we'll also get that will turn positive because you're squaring it, so that's just x squared. Okay. So next what we need to do is multiply these two together. Like so. But we only need to get terms which are going to give us less than or equal to x squared. So we'll do 1 times 1 is 1. We'll do 1 times a half x. And we'll do 1 times 3 over 8x squared. We'll do 2x times 1. We'll do 2x times a half x, which is x squared. We won't do 2x times 3 over 8x squared. We will do minus 2x squared times by 1, but we won't do minus 2x squared times by anything else. Okay, let's simplify. We have a half x and 2x is 5 over 2x. And we have 3 over 8x squared minus an x squared, so that's minus 5 over 8x squared. And that is as required. A student substitutes x is equal to a half into both sides of the approximation shown in part A in an attempt to find root 6. Give a reason why the student should not use a half. Well, if we look at this one, that's only valid when 4 over x modulus is less than 1. So that means when x is less than or equal to a quarter. So x equals a half is not valid. The student substitutes x equals 1 over 11 into this to attain approximation from root 6. Oh, why do I, sorry, yeah, just substitute that in and then obtain root 6. Okay. So we'll sub it into both sides, and let's just do that on my calculator here. So I'm going to do 1 over 11, execute, and then I'm going to do the square root of fraction 1 plus 4 lots of the answer over 1 minus the answer. Okay, that gives me root 6 over 2. And that is equivalent to subbing it into the expansion. So I'll do that by doing 1 plus, oh no, I need to do 1 over 11 again. Execute, and then 1 plus 5 over 2 times by the answer minus 5 over 8 times by the answer squared. Okay, that gives me 1183 over 968. So we'll just multiply both sides by 2. And it gives me 1183 over 484. Brilliant. Okay, we have a vintage car. The value of it t years after it was first valued on the 1st of January 01 is modelled by this equation. Given that the value of the car was this on the 1st of January 05 and then that on the 1st of January 2012, find P to 4 decimal places. Okay, I hate questions like this because I find it really hard to figure out what t is equal to. Right, so let's not overcomplicate it. 2001, and then it goes to 2005. So surely that means that t equals 4. I hope so. And for this one, 2001, that must be t equals 11. It's 11 years from there to there. Yes. It's funny how sometimes counting can be really difficult. Okay, find p to 4 decimal places. Right, so we need to just sub in the two values that we have, or the 2 bits of information we have. So we know that 32,000 is equal to p to the power of 4, and we also know that 50,000 is equal to p to the power of 11. So let's divide one equation by the other. And probably should have written them the other way around, but we're going to divide up. So the left-hand side becomes 50,000 divided by 32,000, which is essentially 50 over 32. And this side, the a divided by the a will cancel, but the p to the 11 divided by the p to the 4 is p to the 7. Okay, so to find p, I need to do the 7th root of 50 over 32. Can't do that one in my head. So I need to find that button on the calculator where you can take the roots that you want to do. Can't find it. Alright, don't panic. Don't panic. We will just do 50 over 32 to the power of a 7th. Okay, slightly embarrassing. But anyway, 1.065, how many decimal places do you want? 4 decimal places. 0658. That will do. That will do. Okay, now it says show that a is approximately that amount. Okay, well, let's just use one of the equations then. Let's use the 32,000 is equal to a multiplied by p to the power of 4. So what we're going to need to do to solve that is we're going to have to do 32,000 divided by that p value to the power of 4. Great. So a is equal to 24796.80, which is approximately 24800. Great. With reference to the model, interpret the value of the constant a. Okay, so a is then multiplied by p, and when t is 0, the value is just equal to a. So a is equal to the value on the 1st of January 2001. And p, I should say the value of the car. You know, they are quite pernickety about things like this. I can't bother to write it down now, but the value of the car on the 1st of January 2001. And then the constant p is the rate at which it increases value. So it is the rate at which it increases value per year. So you multiply that, well, the value by that each year. So it's the rate at which it increases value per year. Okay, and then using the model, find the year during which the value of the car first exceeds 100,000. Oh no. Okay, let's get rid of the calculator to get some more space. So what we're going to have to do, it exceeds 100,000, so we do A multiplied by P to the power of T needs to be greater than 100,000. So we'll divide both sides by this 24,800. Okay, so I'll do 100,000 divided by 24,800, and I get 125 over 31. Fine, that'll do. 125 over 31. And then what we'll do is we'll take logarithms of both sides. You can, doesn't matter, natural log or log base 10, it doesn't matter. So I'll just do natural log. Oops. So natural log of 125 over 31. And then we can bring the t down using log rules. And then we can divide both sides. Like this. Now this should be fine because the log we're dividing by is bigger than 1, so it is a positive number, so it's not going to flip the sign over. So I just need to do that calculation on my calculator. So that is ln of 125 over 31 divided by ln of 1.0658. Okay, we get 21.8. Okay, so we know that it needs to be the time needs to be greater than or equal to greater than 21.88. So actually the question says, finding the year during which the value of the car first exceeds that amount. So we know that any time after this time, it will be above 100,000. But when exactly is this time? Well, 21 years have passed, so therefore this date here will turn into 2022. But we haven't got to 2023 yet. So it's actually going to happen sometime during this year. So the answer is year equals 2022. Okay, question 13 is an integral, which is not obvious how to do it, and most of the time they give you substitutions, but they've not done so here, which is a bit nasty of EDEXCEL. We can't use reverse chain rule because because there's an x here. So essentially what I'm going to do is I'm going to say let u equal x plus 2. Or will I? I think I might say let u equal the square root of x plus 2. I think that might be easier actually. Yeah, okay, let's see how this plays out. If you ever do get a substitution like this, let's square it straight away. We don't want to be doing taking derivatives of square roots. It's just not nice. Okay, now we can differentiate both sides with respect to x. Now u is a variable, so we have to do that implicitly. So I differentiate it like I would do like normally with respect to u, but then I need to multiply it by du by dx. That's how I differentiate u squared with respect to x. Now the right hand side, x with respect to x differentiates to just 1 and the constant goes to 0. So this tells me that 2u du is equal to dx. Okay, that's going to be helpful. And next, let's rearrange for x as well, because we know we're going to be substituting that in. So just rearranging this equation here, this one here, is going to give me, well, x equals u squared minus 2. Now, as I was doing that, I just thought to myself, well, someone might ask, how did I know to use this as a substitution? Well, I mean, just practice, essentially, but also you look for the most annoying part of the integral. Like if I was to replace that with a u, it would make the whole thing so much nicer and easier. So look for the most annoying part and then try and substitute that out. But most of the time, given this is 2018, is the first iteration of this new spec papers, they tend to give the substitutions. They were being a bit nasty for the first people. Okay, right, so actually, I got distracted, too much talking. We need to change the limits as well. So we have x and we have u. The x limits are 2 and 0. To find u, I need to sub it into this just yellow bit here. So 2 plus 2 is 4, rooted gives you 2. And subbing in 0 is going to give me root 2. So those are my new limits when I'm now integrating with respect to u. So it will be 2 and root 2. 2x is the first part, which is going to be 2 lots of u squared minus 2. And then we're multiplying by the yellow bit, which is just u. And that is now with need to substitute out dx, which is 2u du. So we're multiplying by dx, which is 2u du. Okay, let's expand all of this out. So we're going to get 4, u squared minus 2, a u squared. Okay, so all I've done there is just do the 2 times 2, and then the u times the u. So I don't want to do too many steps at once. Okay, now let's expand out, and we get 4u to the 4 minus 8u squared. Okay, now we can integrate, so up the power, divide by the new power. Up the power, divide by the new power. Between 2 and root 2. Okay, so subbing in 2, 2 to the power 5 is 32, times by 4 over 5. So 32 times 4 is 128 over 5. Subbing in 2 cubed is 8, times by 8 is 64, so that's 64 over 3. Okay, so that's the 2 part done. And then the root 2 part. Root 2 to the power 5 is 4 root 2, times by 4/5 gives you 16 root 2 over 5. And then we are taking away root 2 to the power 3 is 2 root 2, times 8 is going to give you 16 root 2 over 3. Okay, I think I'm going to use my calculator. Okay, so 128 over 5 minus 64 over 3 is 64 over 15. Okay, phew, that's going to work. 64 over 15. Okay, let me just write that down here. 64 over 15, and then we're minusing. Okay, so we've got 16 root 2 over 5 minus 16 root 2 over 3. Okay, so minus 32 root 2 over 15. So that's minus 32 root 2 over 15. Okay, great. So there's a plus sign now in between them because of the two negatives. We can take out a 32 over 15, and that leaves me with 2 and root 2. Perfect. And that is what they asked for. Yay. Question 14, we've got parametric equations, and we need to show that all points satisfy this equation. Okay, so we need to substitute one into the other and eliminate t. So rearranging and for sine t is going to give me this, and rearranging for cos 2t is going to give me this. Now we know that cos 2t from our double angle formulas is 1 minus sine squared t. Sorry, watch out. 1 minus 2 sine squared t. So we can now substitute in. So I can write y minus 4 over 2 is equal to 1 minus 2, and instead of using sine t squared, I'm going to use this. So it's x minus 3 over 2 squared. Yeah, perfect. Okay, right, let's expand out then. This is 1 minus 2 lots of x minus 3 squared over 2 squared, which is 4. And then we're going to times both sides by 2, which is going to give me 2 minus 4 lots of x minus 3 squared over 4. We'll see these are going to cancel. So I'm left with y equals 2 minus x minus 3 squared, and then plus the 4 over gives me this. So y equals 6 minus x minus 3 all squared, which is perfect. That is exactly what we want. Excellent. Okay, part A done. Now we go on to part B, and it asks us to sketch the curve. Okay, so I'm just going to draw a little axes here. Something like that. And what we're going to do is we are going to substitute in. And let's first off realise that the t variable is from 0 to 2 pi, which means that x only can take certain values. Sine, as we know, is bounded between -1 and 1, of which, because we are t is equal to 0 to 2 pi, we will get both -1 and 1 and all the values in between. So therefore it tells me the domain of this function that we're drawing. Remember, because we are drawing C, we're not drawing the quadratic itself, we're drawing the actual curve C. Its domain will be from when sine t is minus 1, which is going to give me x is 1, and when sine t is 1, which gives me x equals 3 plus 2 is 5. So the domain is between 1 and 5. So let's first off see, when I sub in x equals 1, then what do I get? Well, I get y equals 6 minus 1 minus 3 squared, and that gives me 2. So there is my first point. Let's just draw it like here. That's the point 1, 2. And also we can sub in for the other the other end of the domain, which is 5, and that also gives me 2. So when x is 5 over here, we're going to get 2 over here as well. And also you might note that when x is 3, we're going to get to the maximum point, because the squared bracket will be 0 when x equals 3, which will leave us just with y equals 6. So therefore we've got this point in here, which is at a height of 6, and a x value of 3. So drawing the curve, it's going to look like this. That's not very curvy. Okay, that's better. He says, explain briefly why C does not include all the points on that quadratic graph. That's because this is the domain. Is the domain of C. So that does it. That's the domain. So we're not doing all of the points. We're not doing all of x in the reals. We're just restricting it to the domain, which is x is between 1 and 5. Okay, great. Now the final part says this line with this equation, which I'll just write y equals minus x plus k, just to get it into y equals mx plus c form, intersects at 2 distinct points. So state the range of k. Well, we know that it's got a gradient of minus 1. So let's imagine that this might be the line we're looking for. Well, that only intersects once, right? So that's no good. Well, maybe it's this one. Again, that doesn't intersect enough times. Maybe it's this one. No, it's not. In fact, the first time it's going to intersect twice is when it goes through like this. Yeah, so that's going to be the first one. And then the last one is going to be when it's tangent to the line, because that only intersects once. So any lines in between these two green ones, let me just get rid of these ones which were demonstrating that's not the case. So any line in between those two green ones there will intersect exactly twice. So that's what we're looking for. Okay. So first off, we know this point here is 5, 2. And we know that line, the green line, has an equation like this. So we just sub in and we can find the k value. So we get 5 is equal to minus 2 plus k. So therefore k is equal to 7. Okay, so that's the first green line. The second green line is a bit trickier because we need for that green line there to intersect with the curve and to have only one solution. So what we need to solve is the line intersecting with the curve, and then we need to state that there's only one solution by checking the discriminant. Okay, so how do we solve this? Well, we set the two equations equal to each other to find where they intersect, which looks like that. I'm then going to expand out these brackets, get x minus x squared, we'll get minus 6x, but then times minus, so plus 6x, and we'll get plus 9, but then that's minus, so minus 9. Bring it all over to one side. Let's bring it all over to this side, so we get a positive x squared. Move the 6x over to get minus 7x. We will get minus 3 comes over to make plus 3, and plus k equals 0. Okay, so that quadratic, when solved, will tell us where the intersection points are. But what we need to do is find the particular value for k for which the discriminant is equal to 0. Because when the discriminant is equal to 0, that means there's only one intersection point, which means the line is tangent to the curve. And that is exactly what we want. So the b squared is minus 7. So minus 7 squared. Minus 4, the a is 1 and the c is 3 plus k. And we need that to equal 0. So this tells me that 49 minus 12 minus 4k equals 0. So 37 is equal to 4k. So therefore k is equal to 37 over 4. Okay, wallop. That's brilliant. So those are my two k values. Now, like I said, any line which is kind of in between the two green lines is going to be good. So therefore, our k value is bounded in between those two. And then the final thing to note is that k can equal 7, but it can't equal 37 over 4, because when k is 37 over 4, remember it's tangent, which means there's only one intersection. So we need all the k values less than that, because those ones are the ones that definitely will cut through twice. And just finally, it does say set notation, which I know is a bugbear for lots of students. But it's really easy. You just do a curly bracket, you write k, colon, and then you just write the, in this case, this is bounded, so you can just write it like this, close brackets, and you're good to go. Right, I hope you enjoyed that. If you did, please do like, subscribe, and share, and check out more of my videos. Thanks very much. Bye for now.